Welcome to The Explainer. Today we're strapping into a truly forgotten, wild chapter of transportation history. Picture this. You're standing at a truck stop back in the late 1970s. But instead of that familiar rhythmic rumble of a heavy diesel engine, you hear the high-pitched, deafening scream of a commercial jetliner spooling up for takeoff. That was the audacious dream of the 70s, literally replacing standard heavy-duty diesel engines with jet-style gas turbines in massive semi-trucks and military tanks. It was this wildly ambitious engineering leap that came so close to completely changing the world. To really understand why anyone would even try to put a jet engine in an 18-wheeler, you have to put yourself in the shoes of a 1970s engineer. To them, traditional piston engines were just dinosaurs. They were too complex, too unreliable, way too inefficient, and honestly just not powerful enough. They looked at standard internal combustion and thought, you know what? We can do better. They wanted fewer moving parts, massively more power, and absolute dominance over the highway. So, here's the big mystery we're diving into today. If this turbine technology weighed significantly less than a traditional diesel block, had barely any moving parts, and generated massive amounts of power, why aren't our highways currently filled with trucks that sound like Airbus A320s? Why did this incredible engineering marvel ultimately end up sitting quietly in a museum in Allentown, Pennsylvania? Well, the appeal becomes super obvious when you compare the two directly. Think about your classic diesel engine. It's heavy, it clatters, it relies on all these complex reciprocating pistons, and it requires this massive water cooling system just to keep from literally melting down. Now look at the promise of the gas turbine engine. It is substantially lighter, it's buttery smooth and vibration-free, it pushes out incredible horsepower, and as a huge bonus, it can run on practically any combustible fuel you feed it. Section 1. The physics of heavy vehicles. Overcoming forces. Moving 80,000 pounds of steel requires overcoming some seriously extreme physical challenges. To actually get a massive tank or a fully loaded truck moving, engineers have to calculate something called tractive effort. Basically, it's the exact amount of rotational force you need just to overcome ground resistance. The vehicle's sheer weight pushes down, the earth pushes back, and the drive system has to fight to physically pull that massive machine forward without slipping. It's honestly a constant war against forward motion. You've got adhesion, weight, travel resistance, and the relentless force of gravity on any sort of hill, all pulling back on the vehicle. To beat these exterior forces at 80,000 pounds, you don't just need an engine, right? You need an absolute monster. Section 2, Anatomy of the GT61, the ultimate engine. This was the specific engineering solution designed to outclass diesel in absolutely every single respect. 550. That is how much horsepower this beastly engine delivered. In the 1970s trucking world, 550 horsepower was phenomenal. We're talking hundreds of ponies more than competing projects of its era. Engineers realized that while gas turbines were super expensive to build for lower horsepower applications, once you cross that 500 horsepower threshold, the turbine actually became economically competitive to build compared to a similarly sized diesel block. Now, this engine achieved its incredible efficiency using a brilliant piece of tech called a recuperator. Let's walk through it. First, the compressor draws in fresh air. Second, the recuperator captures the blazing hot waste exhaust and uses it to preheat that incoming air. Third, the combustor burns the fuel super efficiently in this preheated environment. And finally, the free turbine turns all that heat and expansion into pure, raw rotational output. This clever heat recycling gave the GT601 massive, double-digit efficiency gains. Get this. The GT6001 weighed in at exactly 2,178 pounds. That's nearly 1,000 pounds lighter than an equivalent diesel engine. Just imagine having an extra 1,000 pounds of payload capacity for your freight. Plus, the turbine was entirely air-cooled. That means you completely eliminate the weight, the complexity, and the constant failure points of a water cooling system. And belt drives? None. Zero. The whole shebang was gear-driven straight from the turbines. Section 3. The military steps in. A tactical advantage. Naturally, with a power-to-weight ratio like that, it didn't take long for the GT601 to catch the eye of militaries around the globe. Armies crave engines that can operate in the absolute most brutal conditions on Earth. They demanded exceptionally high power-to-weight ratios so their tanks could carry thicker armor and heavier munitions, rather than just lugging around a giant engine block. And crucially, they were obsessed with its multi-fuel capability. You could run the GT601 on practically any hydrocarbon you poured into it. Plus, without a complex liquid cooling system to maintain, the engine was way less vulnerable to taking a hit in combat and bleeding out all its coolant. They actually built a beefed-up 750 horsepower military-spec version of this turbine. And it successfully powered some of the world's heaviest battle tanks, everything from the German M48 to the British Chieftain. In testing, it beat diesel in every single metric and required only a fraction of the maintenance. It really truly looked like the ultimate engine had finally arrived. Section 4. The Turbine Truck Curse, the Fatal Flaws. It seemed like the perfect engine, right? But a fatal complication completely killed the dream. Let's rapid-fire the fatal flaws that brought this giant crashing down. First up, the heat. The exhaust was so incredibly hot, they literally had to pipe it straight up into the air. The unintended consequence? If a driver parked their rig under a tree at a rest stop and left the turbine idling, the exhaust would literally roast the branches above it. Second, the noise. While it was quiet inside the cab, outside, the truck emitted the deafening, unmistakable roar of a jet aircraft. But the real killers? They were regulatory. Federal speed limits were strictly capped at 55 miles per hour, and weight caps were locked at 80,000 pounds. And that regulatory reality was the absolute final nail in the coffin. You see, gas turbines are really only efficient when they are allowed to run incredibly hard. To actually realize the economic and fuel efficiency benefits of the GT601 over a standard refined diesel, the truck needed to haul massive payloads of 97,000 pounds or more, and it needed to do it at high speeds. Because the law legally constrained both the weight and the speed, the turbine simply couldn't stretch its legs. It was basically an Olympic sprinter being forced to run a race in a potato sack. By the late 1980s, the dream was entirely over, and the surviving prototypes were parked permanently in museums. The diesel engine remained the undefeated king of the highway. But it leaves us with a fascinating parallel for today. As modern, highly hyped electric Class 8 trucks begin hitting our highways, promising once again to revolutionize heavy transport with fewer moving parts and massive torque, will they finally be the ones to dethrone the diesel? Or, faced with their own physical and economic hurdles, are they destined to end up as a museum display right next to the forgotten jet turbine truck? That's the big question I want you to take away from our explainer today. Keep questioning what drives our world forward.